Hi everyone. Today we're going to study fundamental trigonometric identities. First, let us define trigonometric identities. In mathematics, trigonometric identities are equalities that involve trigonometric functions and are true for every value of the occurring variables for which both sides of the equality are defined. In this video, we are going to consider four types of identities. Number one, Pythagorean identities. Second, even-odd identities. Number three, reciprocal identities. And number four, quotient identities. Let's begin with Pythagorean identities. The first identity for this group is sine square theta plus cosine square theta equals 1. Second, 1 plus cotangent square theta equals cosecant square theta. Third, 1 plus tangent square theta equals secant square theta. The even-odd identities relate the value of a trigonometric function at a given angle to the value of the function at the opposite angle. The first identity is the cosine of negative theta is equal to cosine theta. Second, the secant of negative theta equals secant theta. Third, the sine of negative theta equals negative sine theta. The fourth, cosecant negative theta equals negative cosecant theta. Fifth, tangent of negative theta equals negative tangent theta. And the last, cotangent of negative theta equals negative cotangent theta. For the reciprocal identities, the first identity is sine theta equals 1 over cosecant theta. Second, cosine theta equals 1 over secant theta. Third, tangent theta equals 1 over cotangent theta. The fourth, cosecant theta equals 1 over sine theta. Fifth, secant theta equals 1 over cosine theta. And the last, cotangent theta equals 1 over tangent theta. The last group is quotient identities. Tangent theta equals sine theta over cosine theta. Second is cotangent theta equals cosine theta over sine theta. We are going to simplify trigonometric equations using identities, and here are the general points. Number one, simplify both sides of the equation using appropriate identities. Number two, preferably convert all functions into sine or cosine functions and apply algebraic simplifications. Let us have example 1. Verify tangent theta cosine theta equals sine theta. we can see in this problem that the right-hand side is already simple, so we're going to simplify the left-hand side to make it equal to the right-hand side. I will copy the left-hand side member. Again, this is tangent theta, cosine theta. I am going to convert all functions into sine or cosine. So the tangent theta here, I will convert into sine or cosine function. The second, the cosine theta is already a cosine, so I will leave it as it is. Using the quotient identity, I know that tangent theta equals sine theta over cosine theta. I am going to use this value to replace the tangent theta here. So the left-hand side becomes sine theta over cosine theta, replacing the tangent theta, times the cosine theta I simply copied. And from here, I can see that the cosine theta can be cancelled with the denominator, which is cosine theta also. After the cancellation, only the sine theta will remain. And we can see here that the left-hand side is now equal to the right-hand side. And we are able to prove that the left-hand side is equal to the right-hand side. Let us have example 2. Verify the following equivalency using the even-odd identities. The quantity 1 plus sine x times the quantity 1 plus sine of negative x equals cosine square x. In this problem, we can see that the right-hand side is already simple and the left-hand side is a little bit complex. So we will simplify the left-hand side to equal that right-hand side. I will copy again the left-hand side here. There is a term here, the sine negative x, to be simplified using the even-odd identities. From the odd identity, we have this sine of negative theta equals negative sine theta. Using this idea, I will now simplify this sine negative x. It is now replaced by negative sine x. And to simplify the plus and the minus, I will simply write minus. So the new left-hand side is 1 plus sine x times 1 minus sine x. In algebra, if we multiply sum of two terms times the difference of two terms, the product will be the square of the first term minus the square of the second term. So multiplying the 1 plus sine x times 1 minus sine x, I have here now 1 minus sine square x. From the Pythagorean identity, we have the sine square x plus cosine square x equals 1. Doing some manipulation on this formula, I will transpose the sine square x on the other side of the equation. The sign will change, so I have now cosine square x equals 1 minus sine square x. This 1 minus sine square x is the same value that I have in the left-hand side, so I can replace this value by the cosine square x. So here it is now. And the cosine square x, I can see that this is now equal to the right-hand side. So we are able to show that the left-hand side is equal to the right-hand side. Let us have example 3. Verify the identity, the fraction, with numerator secant square theta minus 1 all over secant square theta equals sine square theta. In this problem, the right hand side is simple, the left hand side is a fraction, so we will simplify the left hand side to equal the right hand side. I copied the left hand side in here, and then one Pythagorean identity says secant square theta equals tangent square theta plus 1. I am going to replace the secant square theta of the numerator with this value tangent square theta plus 1. So I have here now tangent square theta plus 1 minus 1 all over the secant square theta. If I remove the grouping symbol here, the plus 1 and the minus 1 will cancel each other. So after cancellation, I will now have this tangent square theta over secant square theta. I'm going to split now the tangent square theta and the secant square theta, showing that this secant square theta is a fraction with numerator of 1. And then I am going to convert the functions into sine or cosine. The tangent square theta, I can use the quotient identity. It is equal to sine square theta over cosine square theta. While the 1 over secant square theta, I can use the reciprocal identity to show that this value is equal to the cosine square theta. Substituting now the respective values, the tangent square theta is now replaced by sine square theta over cosine square theta, while the 1 over secant square theta is equal to the cosine square theta. From here, I can see that this cosine square theta can be cancelled with the cosine square theta in the denominator. After the cancellation, only the sine square theta remains. And from here, I can see that this left hand side is now equal to the right hand side. We are able to show that the left hand side is equal to the right hand side. Let us have example 4. Verify the identity, the quantity 1 minus cosine square theta times the quantity 1 plus cotangent square theta equals 1. Let us write the left hand side. So here it is now. Looking at the first group, this is related to a Pythagorean identity, which is sine square theta plus cosine square theta equals 1. If we're going to transpose the cosine square theta on the right side, the sign will change and it will be sine square theta equals 1 minus cosine square theta. This 1 minus cosine square theta is that first group, which is equal to sine square theta. Later, we will do the substitution. While this second group, 1 plus cotangent square theta, there is another Pythagorean identity related to that, and it is 1 plus cotangent square theta equals cosecant square theta. It means this second group can be replaced by cosecant square theta. So let us do the substitution now. So the first group here becomes sine square theta coming from this, and the second group becomes cosecant square theta coming from this. And let us simplify further let us remember one reciprocal identity that says cosecant square theta equals 1 over sine square theta. So this cosecant square theta can be replaced by 1 over sine square theta. So here it is now. The sine square theta is here times 1 over sine square theta. And from here, we can do simple cancellation. That sine square theta is cancelled with the denominator sine square theta. After the cancellation, number 1 comes down. And we can see that this number 1 is equal to the right-hand side of the given problem. So we will be able to show that the left-hand side is equal to the right-hand side. This is our final answer. Let us have example 5. Verify the identity. We have a big fraction here. The numerator is sine square theta minus 1 all over tangent theta sine theta minus tangent theta is equal to another fraction. The numerator is sine theta plus 1 all over the denominator tangent theta. So let us simplify the left-hand side to equal the right-hand side. So here now the left-hand side. Let's start the simplification. We will do factoring in the numerator and in the denominator respectively. Look at the numerator here. We can see that this is a difference of 2 squares. This number 1 is a perfect square. So the numerator can be factored out into sine theta plus 1 times sine theta minus 1. In the denominator, there is a common factor, and that is tangent theta. If we factor out that common, which is tangent theta, the remaining term here is sine theta, then minus what remains here is only 1. And at this point, we can see that there is a common factor in the numerator and in the denominator, and that is the sine theta minus 1. So we can cancel this factor in the numerator and in the denominator. Then we will go to the next line just to collect the remaining terms. In the numerator, only the sine theta plus 1 all over. In the denominator, it's tangent theta. And from here, we can see that this is equal to the right-hand side. It means to say, we were able to show that the left-hand side is equal to the right-hand side. So this is our final answer. I hope you learned something from this video. See you again next time.